This is Mr. Eggleston, and this is quiz 6.1 through 6.3 review for Algebra 2. This is basically what your quiz is going to look like, but there's pretty much double the problems. I think there's a total of roughly 5 questions and with different parts. All right, but when you see question 1, it will be a question very similar to this, except for you only have one of these two. I doubled it just to give you a couple examples, all right? So the first one is write the equation in vertex form. So vertex form, you have to know this because I'm not going to have it up on the board. Y equals A, X minus H squared plus K. All right, where HK is the vertex. So both of these is easy to find the vertex. All right, so that's the easy part. Like for question 1A, I guess you could call it, the vertex is at 6 at 2, 6. All right, 2, 6. So you can instantly write the equation as y equals A, x minus 2 squared plus K, 6, where K is the y value of the point given. So it's plus 6. All right? So now, all we have to do is figure out the stretching factor. To do that, we choose a point. That's not the vertex. I like using the x-intercept if possible. So I'm going to use 0, -6. And I'm going to plug it in and solve for a. So we got -6 equals a times 0 minus 2 squared plus 6. This equals, let's see, 0 minus 2 is -2. A times -2 squared plus 6. That equals 4a plus 6 equals -6. Subtract 6, that's -12 equals 4a. Divide by 4, a equals -3. We know what a is. Now we can write the equation as y equals -3, that's a, x minus 2 squared plus 6. And that's the equation. All right, in vertex form. Notice a is negative, which it should be because, remember, if a is negative, it should be a sad graph. And you can see this is indeed a sad graph. And now that you know it's -3, you know that if you go over 1, you should go down 3. Well, here's 2. The scale is by 2. So here's 2, 3. So it works. Okay, now we could do the same thing for the second one. Here, the vertex is kind of hard to tell. It's -5, and that's 1, 2, 3, 4, 5. So this is at -5. So the vertex is at -5, -5. We can instantly write in vertex form y equals a, x. Now x minus h is x plus 5, because remember your x's are liars, squared minus 5. Now we plug in the point. This one we can't use the 0, right? We can't use the y-intercept. So I'm going to choose this point here, which is -4, -3. You have to choose it. That point the graph passes through. So we'll have -3 equals a, -4 plus 5 squared minus 5. -4 plus 5 is 1, so this is a times 1 squared minus 5, and that's a -3. Add 5, you get 2 equals a, and 1 squared is 1, so a equals 2. And then you can write the full-on equation in vertex form. Y equals 2, parentheses, x plus 5 squared minus 5. And you can kind of see that because we go... Remember, if we go over 1, 1 squared is 1, and we should go up A. This is A, and that's 2. So A is 2. You could have gone it that way also. All right, on question number 2, write the equation in intercept form. Intercept form is when y is 0, so we're looking for the y values equal to 0. Do not get confused by that. That's the x value. As a matter of fact, that's the y-intercept. We are looking for when is y 0. It's at -1 and 1. So we can write in intercept form y equals a x plus 1, that's 1 0, times x minus 1, that's the other 0. Now we choose a point. We'll choose 0, -6, because that, to me, when x is 0, it makes it easy. So I'm going to choose -6 equals a 0 plus 1, 0 minus 1. So we have -a equals -6. Divide by negative, and you get a equals 6. So putting it all together, you get y equals 6, parentheses, x plus 1, times x minus 1. And there's the equation for that table in intercept form. Okay? Now, there we go. That was question number 2, the first one. Here's question number 2, the second one. Again, we're looking for the zeros. So we have a 0 here and a 0 there, and we can instantly write y equals a x plus 1 and x minus 2. All right? Choose a point that's not either intercept. I'll choose this one, which turns out to be the y-intercept. So we got 6 equals a times 1 times -2. So we have -2a equals 6, a equals -3. Putting it all together, we have our equation. Y equals -3, parentheses, x plus 1, x minus 2. All right? I know I'm going fast. You can pause it and rewatch it, slow it down. But I do the quickness is because I want to get this done, have my file size be small. All right, if it gets too big, then it takes forever to upload through the net onto YouTube. All right, write the equation of a quadratic with a vertex. So now I give you the vertex at 3, 5, and I tell you the y-intercept is 12. What you have to do is realize, hey, if the y-intercept is 12, that's 0, 12. Also, they give you the vertex. And so I would use vertex form, y equals a, which we don't know yet, x minus 3 squared plus 5. I would then use the point 0, 12 to solve for a. So plugging that in, we got 12 equals a times 0 minus 3 squared plus 5. That equals 9a, because 0 minus 3 is -3, squared is 9. Plus 5, and this is 12. Subtract 5, you get 9a equals 7, and then a equals, divide by 9, 7/9, which is an ugly fractional answer, but that's what a is. It wasn't that hard to calculate. And we put it all together, and we would have y equals 7/9, x minus 3 squared plus 5. And there you go. Okay. Similarly, write the equation of a quadratic with a vertex at -4, -3, and y-intercept at -10 again. Y-intercept of -10 is 0, -10. In quadratic form, it'd be y equals a x plus 4 squared minus 3. Okay, that's -4, -3. Notice your x's are liars. So yes, the vertex is at -4, -3, but it's x plus 4 squared minus 3. All right, your x's are liars. Plug in the point of 0, -10. So -10 equals a 0 plus 4 squared minus 3. That equals 16a minus 3 is negative 10. Add 3, you get negative 7 equals 16a. Divide by 16, and again you get an ugly a, but that's okay because it was a simple thing to calculate. And we just put it together, and you get negative 7 over 16, x plus 4 squared minus 3. And that's the equation, given that information. Now they give you this equation in vertex form, and they want you to find the following features of the quadratic. Well, the vertex, remember, it's just, the x's are liars, so it's going to be a positive 2 comma negative 3. Axis of symmetry is whatever x is, which is 2, and you just write it as x equals 2. It's a line. And then it says write the equation in general form. So that tells us that we have to take the x minus 2 squared minus 3. To write this in general form, we have to expand, multiply together this. So x minus 2 squared is x minus 2 times x minus 2. And if you FOIL this out, you get x squared minus 2x plus 4, or x squared minus 4x plus 4. So we'll put that in for x minus 2 squared, and this is going to equal x squared minus 4x plus 4 with a minus 3 on the outside. Combining like terms, you end up with y equals x squared minus 4x plus 1, and that's the equation in standard form, or general form. Okay. Then, on the next one, so again, you're going to have to remember to FOIL out to multiply two binomials. So find the following features of the quadratic, the x-intercepts. All right, well, that's easy. It's just going to be, the x-intercepts are going to be 7, 0, and 3, 0. All right, remember you just set each of these equal to 0 and solve. Okay, so you get 7, 0, 3, 0. Notice I wrote them as ordered pairs. I'd like you to too, because the x-intercept is an ordered pair. The vertex, to find it, you found the two zeros, so you find the average of those two. So the vertex occurs at x equals 7 plus 3 divided by 2, which is 10 divided by 2, which is 5. So we know the vertex is going to be at x equals 5. That's the axis of symmetry is x equals 5. And now plug in 5, you get negative 2, times 5 minus 7 times 5 minus 3. So that's negative 2 times negative 2 times 2. So negative times a negative is a positive, so you get a positive 8. All right? So y is 8. So the axis of symmetry is x equals 5, and it's the vertex is at 5, 8. All right? And moving on, write the equation in general form. Well, that's fairly straightforward because they already give it to you in factored form. So what you need to do is just multiply together the two binomials here. So this is going to be negative 2, and now if you FOIL it, x times x is x squared. Okay, so it's negative 2, and then it's going to be x squared. X times negative 3, negative 3x, negative 7 times x, negative 7x. So we get negative 3x minus 7x is negative 10x. And then negative 7 times a negative 3 is a positive 21. Don't forget that there's a negative 2 multiplying the whole thing. So now, what is going on? Okay, so now y equals negative, distribute the negative 2, negative 2x squared, plus 20x, watch your signs, plus 42. 42. Sorry, that's 6, 7. And there you go. And that's the general form. Okay. Factor the quadratics. The last little bit. All right. Remember, you look for product sums with trinomials. So you're looking for two numbers that multiply to negative 24, add up to 2. So what times what gives you a negative 24, and when you add them together, gives you 2. Well, it's got to be 6 and 4. 6 times 4 is 24, and since it's negative, I'll make the 4 negative, and you can instantly write x plus 6, x minus 4, okay? Notice I didn't bother making the box. You could, but when A is 1, there's really no need to, because if you do this, where you put these two here, and then you put 6x and negative 4x, and you start GCFing, right? You know, you look to see what's common here, which is x. You look to see what's common here, and you see it's 6. And then, you know, what goes here to give you x squared, and that's going to be x. Or you could just say what's common between x squared and x. That'll be another x. And the last is negative 4. Okay. And if you double check, and the real check is to know that negative 4 times 6 better give you negative 24. And it does. So if you do that, I mean, you just get the same answer, which is this. This box is really beneficial for a problem like C. That's the way you would do it for C, because A is no longer 1. There's a 3 there, and we have to take care of that. All right, for B, y equals 9x squared minus 36. Remember, when factoring GCF, first step is to pull the 9 out. And you have that. Then you ask yourself what multiplies to negative 4 and adds up to 0. Notice there's no x to the first term here, right? There should be, so you could say plus 0x and stick it right there. So the sum has got to be 0. So what multiplies to negative 4 and adds up to 0? Well, negative 2 and 2. So y equals 9 times x minus 2, x plus 2. And there you go. Lastly is C, and this is where making this little box up here is what you have to do. Okay, this is where you have to use this. So we're going to do product sums, GCF, there's nothing common, so we're going to multiply 3 times 2 is 6, adds up to 7. 6, 7. So what two numbers multiplied to 6 add to 7? 6 and 1. So then we draw the box. Remember, this is where the box comes in handy. That's a horrible looking box. Okay, so I'll draw a box. And I'll put in 3x squared here. I'll put in 2 here. And then I'll put in the two factors we found, 6x and x. 1x, if you will. And then we have to decide, you know, we have to look to see what's common between these two, let's say. It's a 3 and an x, so we pull out a 3x. What's common to these two, which is just a 1, so we pull a 1 out. Because x and 2 are both prime, and there's nothing common between them. And then you could also GCF down this column. What's common between 3x squared and x, and that'll be x. Just x. And what's common between 6x and 2? That's a 2. So we'll plus 2. So when you look at this, you can double check. 3x times x gives you 3x squared. And that's 2. So 1 times 2 is 2, and that's 6x. 3x times 2 is 6x. 1 times x, 1 times x is x. And then when you add those two together, you end up with this. So the factorization is equal to 3x plus 1, x plus 2. And that's the answer. And there you go, in a nutshell. This is a good quiz. And this is really what your quiz is going to look like. All right, I had a different quiz in mind, but I like this much, much better. So this is your review for it, and I hope it helped. Bye-bye.